Hi, and welcome back. We will now be starting to work in the second book that you have, which is the MIS6 book, and it has to do with databases, systems, data warehouses, and data marts. This is like the 1,000-foot view of what databases and database systems are all about. We will be taking a look at chapter 3, and I'm going to break it into two parts so that you'll have a 15-minute section with the first part of the slides, and then I'll do a second presentation on chapter 3 as well. So what we're going to talk about are databases and database management systems. We're going to talk about logical database design and relational database models. We're going to define the components of a database. We're going to summarize the recent trends in design and also talk about the components and functions of a data warehouse. So, in addition to that, there's what's called a data mart, and we're going to talk about the functions of that. We're going to talk about business analytics and how it plays a role in decision making, and talk about big data and how it applies to business applications. So, let's get the basic definitions out of the way. So when we talk about a database, we're talking about a collection of related data stored in a central location or in multiple locations. When you're talking about databases, there's always going to be a data hierarchy or a structure. The DMS or the DBMS is the database management system. It's actually the application that's used in order to manage a database. So here's a flow chart, more like a Visio diagram of exactly what the interactions are like between a database management system and a database. So this kind of gives you a big overview of how it works. So the components of the database are the user. Then you have the application, which the user uses in order to access the database management system. And the database management system then goes in, and that's the physical layer where all of the data resides. So if you take a look, this is showing you how you would use or how SQL would work in a database. What happens is when you use SQL, you're still the user, but what you're doing is you're using a query to query the database and get information from the database. So there's in the organizational database system, there's a whole host of things that are a part of it. There's the HTML and the VBS script, or the VB script, pardon me. There's the drivers, the registration, the application. Oracle would be the type of database you would be using. There's an auto database and a driver database. And these are all things that are part of the organizational part of the database. And as you start to use databases, it will become more understandable for you. There are different types of data that are in a database. There's internal, which is collected from within the organization. And then there's external, which come from a variety of sources that are not internal to the organization. The external is usually stored in a data warehouse, and the internal is stored in the internal databases. So methods for accessing files. Usually there's what is called a sequential access file structure. So records are organized in a certain way. or a sequential order so that you can actually do a query or a search to find things. There's also what are called primary keys, which are in the college here we use the primary key, which is the student ID, and that's really what you use for a lot of lookups. There's also a random access file structure, and it's records that can be accessed in any order, and it doesn't matter about the physical location. It's fast and effective when you have a small number of records, but if you have a large number of records, it does make a difference if you have the random access or whether you have the hierarchical access. So index sequential access method is a where records are accessed sequentially or randomly depending on the number being accessed. So as I was saying, the random access is usually for a small number and sequential access is usually for a large number. What it does is it uses an index structure that has two parts. It has an index value and then a pointer to the dislocation of the indexed value. So there's the physical, in a logical database design, there's the physical view, which involves how the data is stored and also how you retrieve it. It's usually hard disk, magnetic tapes, and CDs. The logical view is how information appears to the user, how it's organized and how it's retrieved. So there's different database designs you can use. The data model it determines how the data is created, represented, organized, and maintained. So it has a data structure, the operations around the data structure, and the integrity rules. The hierarchical model has relationship between records that form like a tree-like structure. So there would be connections between different records. Excuse me. So here's a look at a hierarchical model, and you can see that this almost looks like a tree, or it looks like a pyramid almost, where you have the parent and then you have siblings. So there's also a logical database design that uses the network model. It's similar to the hierarchical model, but it models records in a different way or organizes them differently. It can have multiple parents and multiple child records. So here's a look at a network model. And as you can see, they're using it in a situation where you have invoices, payments, and customer numbers. The relational model, what it does is it uses a two-dimensional table of rows and columns of data. So when you think of rows, you need to think of records. When you think of columns, you need to think of fields. And a data dictionary is just stored definitions of what kind of data types you have and what kind of data rules and what kind of values are associated with them. So there's a primary key and a foreign key that are used as part of a relational model, and each one of them can tie back to one another. The primary key is a unique identifier for a record in a relational database. A foreign key is a field in a relational table that matches a primary key column in another table. And what it's used to do is to cross-reference between. So if you have a primary key, you can access information about another table, which may have information about a product that is being purchased by the customer who has the primary key as their ID, and they're purchasing a product which is a foreign key. The product number might be a foreign key, but it has information in another table, and it's used to cross-reference perhaps what they purchased in a month or in a year. So here's an example of how primary keys and foreign keys work. And in this case, the employee ID is actually the primary key. And the primary key it associates with a foreign key in another table, which happens to be the position table. So there's a position ID that in another table is the primary key, but the employee table, which has the employee ID as the primary key, is using the employee ID as a foreign key in the position table so that you can do cross-referencing. So there's also what's called a rational model and the use of normalization. And what happens is it improves the database efficiency by eliminating redundant data. So what it does is it only stores data in one place, and after that it does not have redundancy of that data in the table. So then you're not taking up space with additional information that you really don't need to store because it already exists in one place. So what a relational model does, it retrieves data from tables using operations that pick and combine data from one or more tables. So we're going to start talking a little bit about SQL. SQL is a language that is used, or it's a query language that is used in order to be able to find records or find information in a database. And the kinds of things that it does is it selects, projects, joins, there's intersections, unions, differences. Those are the kinds of things that you would use to work in SQL. So the components of a database management system are the engine, the data definition, the manipulation of the data, the application generation, and the data administration. So let's talk first about the database engine. That's the heart of the database management system software. It's responsible for the data storage, the manipulation of the data, and the retrieval. And it converts logical requests from a user into their physical equivalents. So that would be by doing a query and finding information. Data definition. It creates and maintains the data dictionary. It defines the structure of the files. You can add and delete fields. You can change field sizes and data types. Manipulation, it's exactly what it sounds like. It is the ability to be able to add, delete, modify, and retrieve records. And you would use something which is called SQL. That's what we use mostly here at Madison College. It stands for Structured Query Language. And you use several keywords in order to find things. There's also something called QBE, which is query by example. And what you do is you request data from a database by constructing a statement form by query forms. I really don't use that often. Most of the people I work with use SQL. Application generation. So those are the elements of an application that are using a database. There may be data entry screens, interactive menus, so it's more of a GUI type of situation or a graphical user interface. It's used a lot by IT professionals and database administrators. And here are the components of a database system. So I'm going to present the second half of the chapter 3 in this book in the next video.